All right there, Algebra 2. We're going to move into chapter 4. We're going to skip around in this chapter just a little bit. You're expecting to see something about factor by grouping today, but I do want to take an extra minute today and just go over our warm up real quick. It is at the bottom of your page if you're in my class. If not, just kind of jot it down and go along with it. A over B is 2. So notice what I see over here is now B over A. So what's that mean? Well, that means this must be 1/2, and then we have 4 right here. We're going to stick that in the numerator and multiply here. So 4 over 2 is just 2. So that might be the value as we look at that. And by might be, I mean it exactly is. All right. You guys are faced with some SAT style stuff coming up. So I just want to make sure we get an idea. Notice that trend, A over B, 2 over 1, so b over a must be 1 over 2. Even if it was something greater than that, it reduces to that, so that's what we'd have to use. Notice what happens in our second one is we're kind of flip-flopping the location of our variables just to try and confuse you, right? You might go ahead and be like, oh, if I just multiply the bottom by 4, well, that wouldn't work because right, that's an x and that's a y up top. So as I rewrite these, here we go, 3x plus 4y equals negative 23. Let's see. Do you want to go 3 times the x? You want to do 3 times 19, or you want to do negative 2? Let's go with negative 2. All right, so that means I'm going to get 2x, so that works out nicely. I'm going to get negative 4y. That's what we're after, and negative times negative is positive, and 19 times 2, well, that's basically 20 times 2. It's 40, but it's too short, so it's 38. So we're going to get rid of those. So we got 5x equals 15. X turns out to be 3. And this might be the worst multiple choice question I've seen from an SAT prep because there's only one choice there. Obviously, you want to check it, plug in your 3, make sure you get negative 8, and then we're in good shape. All right, let's scroll to the top of the page then. Okay, I just don't want to forget some of those things that we have done already this year. And the way it's presented there is kind of nice. Quick refresher. All right, GCF. What in the world's a GCF? I don't know. Uh, 18 and 24 are both divisible by 2. Yeah. All right, Mr. Tola, I got it. It's 2. I'm like, I'm sorry. That's just a common factor. It's not the greatest. You're like, you're right. You're right. It's 3. It's 3. It's definitely 3 because they're both divisible by 3. I'm like, no. See, if it works by 2 and 3, it must work by what? 19. No, it doesn't work by 19. The number is 18. It's 6. Remember, it's 6. All right. I was just kidding. None of my students say that anymore. I'm just kidding. I'm just kidding. Kind of. All right. So here's the next thing. We got r cubed and r squared. In algebra 1, we talked about this is r times r times r, and this is r times r. So they both have at least 2, so we're going to use r squared. This is the greatest common factor. What would be left? Would be left. So 24 divided by 6 is 4, and r cubed divided by r squared is an r, minus 18 divided by 6 gives me 3, and r squared divides it out completely. Right, so here's one thing I want you to make sure you do as we work with some factoring. If you have a binomial and you factor something out, like a greatest common factor, what is left must still be a binomial. Okay, reason to point that out is sometimes we kind of like, if it divides out completely, we forget to put a 1 in. Okay, so we got to make sure we do that. All right, on the bottom, what do we got going on here? 3 times x minus 5 and 2 times x minus 5. Guess what's in common? This whole x minus 5. So how might I write my answer? Well, normally we say the GCF, so x minus 5, and then we write down, okay, 3x times x minus 5. If I divide out the x minus 5, it's just 3x. Plus, if I divide out my x minus 5, it's just 2. You're like, holy cow. That's kind of what we're going to be after here in this chapter is factoring regular old trinomials and see what happens with them. But to do that, we're going to use factor by grouping. So here's what it looks like. Now, these aren't trinomials. This just sets the stage. So factor the first 2 terms and the last 2 terms separately. So I'm going to underline them separately. In both sets, I should have parentheses around the same thing and take out the common part for both halves. All right, so let's say GCF 6 and 2 is 2. X squared and x, they both have an x. So let's divide. 6 divided by 2 is 3. Let's take out an x minus, here it is, 2x divided by 2x is 1. All right. Now, here's what I do. I teach my students, I'm like, you know what? These have to be the same thing, right? This is key in here. So go ahead, leave a little space and write 3x minus 1. Because if I can't make this happen, that means I can't factor it by grouping. So there's no harm in doing this. So what's the GCF of 3xy and y? Because I want to know. I know you said why, didn't you? Okay, because I want to know. All right, now let's regroup this so we can write our final answer. So that means my GCFs go together. 2x plus y, that makes up a binomial, and I need 3x minus 1. I need just one of those because I had those twice. All right, that's the whole thing. That's factor by grouping. Hopefully you got that in Algebra 1. Otherwise, we're going to take it easy. We're in the world of pandemic here, so I'm not trying to do too much all at once. All right, first two, although I will give you a heads up, this problem I made a little bit worse. All right, 6 and 9. 6 and 9 both divisible by 3, h to the fourth, h to the third. All right, h to the third it is. 2h, how'd I get that? 6h to the fourth divided by 3h cubed plus 3. I need 2h plus 3, right? Like this has to happen. Okay, so that also helps me identify what's the GCF of 12 and 18. Well, all I have to do here is say 12 divided by 2 would give me 6. And 18 divided by 3 would give me 6. So then my GCF is 6. H squared and h. So I have to take an h out of this one as well. Now these GCFs are going to go together. 3h cubed plus 6h times what? 2h plus 3. That's what. All right, now this first one, all right, I want you to look for this. I'm not going to do this very often, right? But I want you to make sure you look for it, just like we went and we did the SAT review stuff. If this happens to have, that's really hard to see now. Let me get rid of those. If your GCFs have a GCF, we need to look for that. Okay, otherwise it's not complete. Okay, it's a factory completely question on the SATs. This answer would be here, but it's not the final answer. 3 and 6 are both divisible by 3, and they both have an h. So h squared plus 2, 2h plus 3. So if we're looking for all the factors, this is what we're looking for. Okay, I'm pretty sure this doesn't happen anymore today, but we're going to look for it. Now, I knew that was going to happen in the beginning because they all had at least an h. Okay, so some things we can look for. I could have done a GCF of 3h for the whole thing and then went through the process, but it's not required. Okay, we'll get there either way. Factored form, here we go. Let's do this again. First two, 8 and 16, that's an 8. T cubed and t squared. Let's go with t squared. So I got t plus 2. I need what? T plus 2. All right, so the GCF here is 5. So how do we write my answer? GCFs go together. 8t squared plus 5 and t plus 2. All right, there's no GCF of my GCFs, so we're in good shape. All right, we're going to factor our expression again. First two, second two. Here we go, 20 and 8. Let's see, that's divisible by 4. Let's go with r squared. So I get 5r plus 2. I need 5r plus 2. So 15 divided by 5 is 3. So I think this is 3. 6 divided by 2 gives me 3 as well. Okay, so that works. Okay, see how that's really nice to write out that that does work and gives us kind of a lead in to what we're going to do with it. All right, GCFs go together as I ramble on here. 5r plus 2. Look at that. I even left it as r's. So any of you guys that really know me, I change all the problems to x's because of my excellent penmanship. I don't want it to look like something else. All right, so here's this one. Can we factor it using grouping? I don't know. Let's take a look. First two, 2 and 6. All right, so here's 2q squared. So 3q plus 2q squared divided by 2q. All right, so that has to be 1. So 3q plus 1. This is what I need to get. All right, so 12 and 3. Okay, GCF is 3, but 12 divided by 3 would give me 4, so that doesn't work. Okay, so my answer is no, okay, because I can't replicate this binomial. Okay, the other thing that I know is this sign right here would have to turn positive, which means my GCF would have to be negative, but then it's going to flip-flop this sign. Okay, so we're also going to have a sign issue here. So we have multiple reasons that we can't match the binomial. That's the easiest one. And by matching it, we mean by the GCF and also the sign of the GCF. Okay, so what we do with it, we'll teach you that later this year or in pre-calc. If you want to find out some solutions, we're going to throw that on the graph and see where the x-intercepts are. That's what we're building up to. All right, so we got some weird sign things going on here. right? I got minus, I got plus, I got minus. So let's see what happens. First two looks like x squared. So I get x minus 5. What do I need to get? X minus 5. Okay, so this sign matches. So I'm going to start pointing that out now. So that's a good thing because 2 and 10 are both divisible by 2. So 2x divided by x is 2. 10 divided by 5 is 2. So that works. So x squared plus 2 and an x minus 5. So that works out very, very nicely. Oh my, look at all this stuff going on. Okay, it doesn't matter what type of alphabet soup we have going on. Just do it like you normally have. First two, second two. 6 and 15, 3. They both have an x. So I need 2y minus 5. We'll take out the x, so I'm going to leave a little space, 2y minus 5. So you see how writing this again really helps. So if I have 2my and 5m, we just have to take out the m. And I want this sign to stay the same, so I'm going to keep it positive m, because I don't want to change any of those signs. We'll have one of those in a minute here. GCFs go together, 3x plus m, and 2y minus 5 makes that a whole lot easier. Look at that, we're on a roll. We're like butter. Yeah, nobody said that since like I was in high school. So I'm going to stop saying that. Or I'm going to completely bring it back and we're all going to be saying it by the end of 2021. Unless, of course, you're watching this video in the future. And I don't know what year it is. All right, let's do this. XY and 4y, they both have a y. X plus 4 is what needs to be left over. X plus 4. All right, remember I said I'm going to keep circling signs. Here's why. I need you to change this sign, which means dun, da, 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 your GCF has to be negative. 3 and 12 is 3. Negative 3. Okay. So if that sign has to change and you're like, wait, does that change this first one? It sure does. Negative 3x divided by negative 3 is x. If you're really not sure and that seems weird, do this mentally. Okay. If I distribute, do you get what we started with? Negative 3x, negative 12. Yeah. Then we didn't break any math rules. GCFs go together. Y minus 3 and x plus 4. All right. You're doing a great job, by the way. Oh, I am too? Thank you so much. All right. First two, second two. All right. 15x and 3z. All right. So the x and z, they're going to stay, but it looks like 3 is going to work. So 3, 5x minus the z, 5x minus the z. All right. So my signs, right? Now we're keeping an eye on that. It stays the same. So I'm going to use positive, and it looks like they both have a y. Right? 5xy, take out the y. YZ, take out the y. Okay, so 3 plus y and 5x minus z. Not too bad. Just a couple left here. If you want to pause the video or shut it off or whatever, as long as you get these right and you're all set, then that would be okay. I see variables throughout, but I don't see the same variables, so I'm not worried about a GCF on top of my GCF. So let's go first 2, 8, and 10. So 2x squared, so I need 5x plus 4. See if we can't make this 5x plus 4. All right, what do we have to take out? Looks like 15 divided by 5. This will give me 3. And xy and 12y, so they need a y out of there as well. And all those signs are positive, so it's going to stay that way. So 2x squared plus 3y times 5x plus 4. So again, I hope that you went over this in Algebra 1. If you didn't, I hope I'm doing okay for you here. Here we go. 2 and 10. All right, so 2 it is. X cubed, x squared, so it's x squared. So I get an x minus 5. Leave some space, x minus 5. I have some different signs, so I'm just going to double check here. That has to stay the same, so I'm going to put a plus in here. 4 and 20, that's a 4. All right, so here we have 2x squared plus 4 and x minus 5. Let me hit my highlighter. You're like, why are you hitting the highlighter? 2x squared and 4, what's the GCF, my friend? 2. X squared plus 2 and x minus 5. So notice that's only going to come out of the first binomial. It doesn't have to go out of both. And it shouldn't, technically. All right. Yeah, let's do this again. Here we go. First two, second two. I got a lot of signs, right? And this one's definitely going to be plus, so I'm going to have to take out a negative in the second one, but we'll get to that in just a second. 3, no 3, so just an x. 3x plus y. I need 3x plus y. I need this to sign change, so I'm going to use a negative and it looks like a z. So x minus z times 3x plus y. And then we are in good shape because x and z, there are not going to be much else we can do with that. All right, I think that's all we have today. So good job hanging out with that. All right, so we got them all. All right, so the steps are very generic, but that's what it is, guys. So let's keep working at it, and we'll work on it in class.